Space Shuttle takes a lot of heat. It's considered to be overpriced and super expensive and dangerous and a waste of time. And generally speaking, a lot of people, while they admit that there's a beauty that goes behind it, they're just not super impressed with it overall, as far as calling it overpriced. But how overpriced was it really? Well, at first glance, it looks pretty awful. The total cost of the Space Shuttle program was about $210 billion for 135 missions, which means it's a cost of about over $1.5 billion per mission. Now, it's not quite that bad. There was a lot of development costs and a lot of money that was spent when it was ongoing, but they estimate that $450 million was the cost for a single mission. Just the mission alone. For that, what did you get? Well, about 27.5 metric tons to low Earth orbit. That's not very much at all. That is far, far less than most rockets. It was one of the heavier payload lifting rockets out there, but a Delta Heavy can lift more payload than that at a cheaper price, and a Falcon Heavy can certainly do that. So it wasn't that efficient for delivering cargo into space. It comes to a total cost of $56,000 per kilogram that could have been lifted, and would be if the maximum cargo was lifted for everything, which is how they usually figure those kind of numbers out. That is quite high, whereas a typical rocket will be 10 to 20,000, and the Falcon series by SpaceX is even less. But one interesting thing, it can carry 16,000 kilograms to the International Space Station. How does that compare to some of the other providers that are out there? Well, let's take a look. So, one of the big things that has been created to determine, because the Space Shuttle was considered so expensive, in part, and there were other things, is the Commercial Crew and Cargo Awards. So we can see that there's been a total of about $18 billion that has been spent on this program in either actuals or awarded money, which is a considerable amount of money. There's no other way to put it. We can see that SpaceX has received the highest portion of that, but there are a number of other companies that have received at least a small portion of that. And there are some great things that have happened because of this. Without this money, SpaceX as a company probably would have died. Tesla, for that matter, probably would have died. And other companies would have had some issues. Orbital-ATK has been able to launch a bunch more rockets. But how financially wise was this decision from just purely the standpoint of supplying the International Space Station? Well, let's take a look at some numbers. So I've done my best I could to determine what is the actual cost for a mission or for the cargo in general. Not all of these numbers are available, and there have thus far been 5 primary mechanisms to get cargo to the International Space Station. You have the Space Shuttle, of course, that delivered most of the modules that are used on the US and European side of the station. You have the Progress, which is a Russian unmanned vehicle. You have ATV, which is a European automatic transfer vehicle. And then you have the Dragon and the Cygnus version 1, because they have a CRS-2 version that I did not factor into the cost of any of this. So I had opted not to go with CRS-2 because they haven't really had contracts awarded for that. It's a little bit too new to really get into the numbers of this. And by the way, all of the sources I have for this data are linked in the description. So if we go and we crunch all of the numbers, I took the maximum cargo and what was a typical cargo. For the Space Shuttle, I used what was the cargo that it carried on its last mission to the space station, which was purely done to bring supplies to the space station. It wasn't done to bring a module or something like that. The truth is you have to consider to some extent both of the values. They could have put a bigger compartment and been able to take more cargo in the space shuttle if they needed to, and that would not have costed a significant amount of money. Okay, so anyways, what do we have? Well, the average cost per kilogram, the space shuttle, assuming the $450 million cost that NASA says that it cost per mission, $67,000 US dollars per kilogram, which seems like a lot of money. Now, how does that compare? Now, the Commercial Resupply mission, they had two parts. They had one part where the company was given some money to develop a vehicle, and then they've had the ongoing contracts. And I've split those into two. I've used those as one common vehicle. Progress and the Space Shuttle both existed before, so they were not developed to resupply the space station. I did not include those values for this point in the study. So what do we have here? It turns out the average cost per kilogram, Progress is probably the cheapest. This $100 million number, it's really, really difficult, though. I don't know how accurate that is. It could be considerably more than that. I doubt it's any more than 200 million because we know that a Soyuz is similar in a lot of ways to a Progress. And the Soyuz cost is around 250 million or something like that. So this could be off by quite a bit. And we don't know how the actual breaks down versus the cargo. But the space station, to use the last space shuttle mission, actually cost less per kilogram to take up than the entire Dragon program does if you take into account the development cost of the Dragon, and the cost significantly less than Cygnus. So this has been considered to save a lot of money, but is it really saving the money that it claims to be? One thing to keep in mind too is the space shuttle can also take people on there too, so there's some value there. Now let's go ahead and compare the people costs, and this is a little bit harder to do because there actually has not been a person that's gone into space through a commercial program, but let's take a look at this. Space Shuttle, it typically would carry about 7 people, but it could carry up to 9 people into space. So that comes out to be 64 million on average and 50 million in your best case per person. The Soyuz, now I haven't adjusted for inflation. If you adjust for inflation, it's probably similar but a little bit less than the Soyuz, which is currently runs about $87 million per person from the numbers that I have received, that I found. Dragon V2, including the development costs, and note that I'm assuming a $200 million per launch. SpaceX has said early on that they thought it was going to be $160 million, but I'm assuming there's going to be some adjustment for inflation and whatnot. And I'm also counting the cost of development of the contract. I'm assuming that they will have a total of 16 crewed missions. The first 2 are part of the initial money that they spent, and that the 12 remaining ones will be split equally between the 2 companies, and that they'll cost the same. So they can take 7 passengers. I think the plan is, for the most part, for the space station, they're going to take 4 on most of the runs, and they're going to stay there. Now, one thing in fairness, the space shuttle cannot stay long-term at the International Space Station, whereas the other vehicles can. So it cannot be used for the emergency capacity. But when you take into account development costs, the space shuttle, in carrying people alone, was significantly cheaper than any other option that's out there now. When you take into the development costs of developing a brand new system to go there, which I found very, very interesting. And it can take cargo at the same time. So one other question that I've had with this is, how fair is it to consider the development costs? So I remove the development costs for these estimates, and what I'm doing is only comparing the Dragon, because the Dragon numbers are the most well published. Comparing Dragon CRS Mission 1 for the cargo cost at its best case capacity, which is not what it actually has been able to achieve because it's not big enough to carry more cargo. And I'm also using the $160 million and assuming that you're sending 7 astronauts every time, so that comes out to be $23 million per astronaut. Using all of those, and I'm also using the cargo capacity that was to the space station for the last resupply mission from the Space Shuttle. That comes out to a value of $425 million, which is not quite what a space shuttle costs, so it's a little bit less. But I don't think it's really fair to hold all of these absolute best case scenarios for SpaceX and to hold the space shuttle in the worst case. If you take into account all of the best case shuttle values, it comes out to be something more like $850 million. The value in terms of commercial resupply, and this does not include the development costs. So what does all this mean? It turns out that the space shuttle, is the single best space station developing vehicle that has ever been developed, and with the only exception of possibly the BFR, it's the best one that is even on paper so far that has had any real development spent into it. It's really a truly remarkable vehicle, and it's given a lot of heat, but it really was a very capable vehicle. And yes, for the purpose of delivering satellites to orbit, it was not your vehicle. It's way overpriced for that. But for achieving and docking with space stations, there has never been a vehicle, including the ones that are currently under development, that was as efficient for delivering cargo and people to the space station as the space shuttle. Or at least this is what the numbers are telling me. Now, I'm sure there'd be lots of questions with this, because this just totally blew my mind to actually crunch these numbers and realize that this is the case. If you guys think I'm wrong, let me know. I really would love to hear this, because I want to make sure that I get this right. This kind of blows my mind a little bit. And let me know whatever other questions you guys have about the space shuttle, space station, or space exploration in general. And we'll see you next time. For now, keep on tracking.